Hello, I'm Sonal Chaudhary from Hach, and today I have here with me Dr. Vidim Malkov, who's from our product management team. We will be talking today about dechlorination, one of our episodes in Ask the Expert series. So on the topic of monitoring, right, it seems like the only solution to this is addressing these challenges is continuously monitoring your feed water. So can you elaborate more on what does continuous monitoring mean, and what are some of the methods out there today where you can measure some of the feed water content while you're dechlorinating?
Another good question. There's more like philosophical underlying here, because continuous may mean anything. Every second, is it continuous? Yes. So usually we use largely continuous and largely discrete. And largely continuous, it's more frequently than discrete. Let's put it this way. So if we're talking grab sample analysis, when you take a sample, operator take a sample, analyzes with whatever instrumentation available, every hour, shift, day, month, week, that's discrete analysis or largely discrete analysis. If there is an instrument analyzer, process analyzer, which measures every minute, every second, every 5 minutes, every 15 minutes, that's more of a continuous or continual method. Therefore, it provides uninterrupted or largely uninterrupted stream of data. So we have basically two extremes here. The discrete analysis provides single points, like a snapshots within whatever time frame is performed. The largely continuous analysis, it provides largely uninterrupted data stream, which gives much better picture of fluctuations of trending and everything, because snapshot versus stream. That's how you should probably look at this, snapshot versus stream. And of course, to better control your process, you should have uninterrupted or largely uninterrupted data, which is a stream, which is online analysis, which is continuous or continual to that extent data.
So to that point, what are some of the current methods out in the market for continuous measurement?
Absolutely. So there are currently available three major technologies, or two technologies with some aspects of monitoring on the market for online analysis of chlorine. We're talking specifically chlorine here, right, for dechlorination. So there are two electrochemical methods. One is ORP, oxidation reduction potential, is a potentiometric method. Another electrochemical method is amperometric analysis of chlorine. And there is on the other hand, is a colorimetric analysis for online chlorine monitoring. The major difference between the two, again, it's underlying technology. Electrochemical technology, first of all, it relies on calibration. There is a default calibration, but it's not stable ever, because the technology intrinsically susceptible to influence of parameters of sample, sometimes environmental parameters. Even chlorine concentration itself may influence the calibration curve. So from that standpoint, a reliance on calibration, it's a major differentiator for online technologies based on electrochemical analysis. Of course, because of influence of the factors such as pH of water, pressure of the pressure and flow of the sample, presence of other interferences such as accidents, etc. Colorimetric analysis, on the other hand, it has a very stable, established by the Lambert-Beer's law calibration curve, which is not influenced by those factors such as pH, temperature, flow, etc. From that standpoint, it's a huge advantage. Now, if we compare side by side those two methods, there are advantages and disadvantages of each of them, or each of the technologies. For example, speaking of continuous, electrochemical methods, they can measure, they can provide response every second, if you wish, to the systems, the monitoring system, the controllers, what have you there. And this is very much uninterrupted data stream. The colorimetric analysis is based on the batch principle. So sample is taken inside the analyzer, isolated, analyzed with the addition of chemicals, and then released in a waste stream. And it happens every 2 minutes, give or take, approximately between 1 and 3 minutes, sometimes 5 minutes. This is also largely continuous, but it's not continuous if we're comparing from the standpoint of electrochemical methods. However, besides those factors already mentioned, electrochemical methods have other disadvantages. Calorimetric method has the one big potential disadvantage is reagents use. Reagents use, it creates potentially handling situations, say, necessities. It creates a waste stream of reagents from the analyzer. So that's from nuisance to inconvenience, while again, that's a good advantage of the reagentless electrochemical methods. However, there's always balance between continuous, batch, reagentless, reagent-based. Here is accuracy, here is reagentless. And it's always a question to choose the right method, and the right method to be chosen based on what you need to achieve. What are your objectives? Do you need accuracy or you need fast response? Those are the questions.
Thank you so much, Vadim, for your time today. To learn more about this, visit hach.com webpage for ULR CL17SC.